In our last lecture, we are seeing about principles and the interaction of X-ray with matter. Already seeing in last lecture. In this interaction of X-ray with matter, this is the five important things to be considered. Okay, first one is the concurrent, and then second one is the photoelectric, and then third one is the Compton. First one is the concurrent, second one is the photoelectric effect, third one is the Compton scattering. In our last lecture, we have completed the concurrent scattering and photoelectric effect. So now we are going to study about the Compton scattering. This is the first three thing is the main important, most important of these five interaction of X-ray with matter. Okay, now going to see about the Compton scattering. Now we are going to see about the Compton effect. The Compton effect is the terms used for unusual result observed when X-ray are scattered on some material. Okay, which is used for unusual result observed. Next thing is when electromagnetic wave is scattered off atoms, and then the wavelength of scattered radiation is expected to be same as the wavelength of incident radiation. Is it okay? Going to next. The X-ray are scattered off some materials. Okay, this is the diagram of the Compton effect. This is the X-ray sources. It will be emit the wavelength of lambda. It will be touch the target of graphite. Okay, here now going to see about explanation of the diagram. Such a graphite, the scattered X-ray has different wavelength from the wavelength of X-rays. Okay, the monochromatic X-ray with wavelength of lambda, here this is the wavelength of lambda, are incident to the sample of graphite target. Here target is the graphite. It will be incident on the wavelength of lambda will be incident on the target graphite. Okay, after that where they are interact with the atoms inside the sample. After incident, it will be interact with the sample inside of the graphite material. Okay, and then the later emerge scattered X-ray with wavelength. After the interaction, it will be emit the wavelength of lambda dash, the wavelength of lambda dash. The detector placed behind the target. Here this is the detector. It will be placed behind the target. Okay, and then it can measure the intensity of radiation scattered in direction. It will be used for measure the intensity of radiation, the direction of some direction. The angle will be the theta. Okay, which respect to the direction of incident X-ray beam. Okay, we are going to next slide. This is the wavelength diagram of the Compton effect. Here see the different angle measured here. Here theta equal to 0, here theta equal to 45 degree, here theta equal to 90 degree. In this is the diagram for Compton effect. Measured for the different scattering angle, it will be measured for different scattering angle, that is known as the angle theta equal to 0, and then another one is the 45 degree, and the next one is the 90 degree. The measured for different scattering angle indicates the graph. Okay, one peak wavelength is lambda. The another peak is located at the same other wavelength of lambda dash. Here one peak is lambda, another here second peak is the lambda dash. The two peaks are separated by, that means the called two peaks are separated by the delta lambda. Okay. The x-axis denotes wavelength of the scattered X-rays. The x-axis denotes wavelength of scattered X-rays. Okay. Then y-axis intensity of scattered. Y-axis intensity of scattered X-rays. Okay. And then delta lambda is called Compton shift. Okay. Here delta lambda is called Compton shift.